Warning: engineering content. Few minutes of engineering. Types of Portland cement according to ASTM C150. ASTM separates Portland cement into 10 types under 5 main categories. Type 1, which is an ordinary Portland cement used for general purposes where there are no special extenuating conditions. Type 2 is a moderate sulfate-resistant cement. This type of cement is used in structures exposed to moderate sulfate attacks. Type 2 MH is not only moderate sulfate resistant, but also a moderate heat-generating Portland cement, which is suitable for structures subjected to moderate sulfate attacks and where heat of hydration is of a concern. Type 3 is a high early strength Portland cement, and is suitable for applications where high early strength is required, such as repairs or cold weather concreting. Type 4 is a low heat Portland cement, usually used in mass concrete and hot weather concreting. Type 5 is a sulfate-resistant Portland cement. It is usually used in applications where concrete is subjected to sulfate attacks, such as marine structures or chemical plants. In addition, types 1A, 2A, 2MH, and 3A are air-entrained types of Portland cement which are similar to types 1, 2, 2MH, and 3 respectively. However, an air-entraining agent is added during the manufacturing process. Air-entraining agents are added to provide an increase in the freeze and thaw resistance. What significantly affects the properties of different types of Portland cement is the chemical composition. Portland cement is mainly composed of 4 chemical compounds. Tricalcium aluminate C3A. This compound generates high heat during the hydration mechanisms of cement and has very low resistance to chemical attacks. Tricalcium silicate C3s. This compound generates medium heat during the hydration mechanisms of cement. It mainly contributes to the early strength development, and has a low resistance to chemical attacks. Dicalcium silicate C2s. This compound generates low heat during the hydration mechanisms of cement. It mainly contributes to the long-term strength, and has a moderate resistance to chemical attacks. Tetracalcium aluminoferrite C4AF. This compound generates moderate heat during the hydration mechanisms of cement, and has high resistance to chemical attacks. Thereby, for type 2 Portland cement, which is moderate sulfate resistant, the amount of tricalcium aluminate C3A is limited. For type 2 MH Portland cement, which is moderate sulfate resistant and moderate heat generating, not only the amount of tricalcium aluminate C3A is limited, but also the amount of a certain combination of tricalcium silicate C3s and tricalcium aluminate C3A is limited. For type 3 Portland cement, which provides high early strength, the amount of tricalcium silicate C3s is increased. For type 4 Portland cement, which has low heat generation, the amount of dicalcium silicate C2s is increased. For type 5 Portland cement, which is sulfate resistant, the amount of tricalcium aluminate C3A is more limited than that of type 2, in addition to limiting a certain combination of tricalcium aluminate C3A and tetracalcium aluminoferrite C4AF.